Welcome to the place where we gain knowledge through the lens of creativity. I am Aaron Dworkin, and this is Artful Science. Thanks again for joining me here on Artful Science. Today's show is Falling Off the Edge, Understanding the Cosmos. And my guest is Miguel Aragon, who serves as computational cosmologist, who's really working at the intersection between cosmology, data science, and art. Miguel, welcome to the show.
Thank you, Aaron. Thank you very much for the invitation. It's a pleasure being here.
It's so great to have you here, and you know, this is such a topic that has filled me with wonder since I was a child. And I would walk to our local movie theater to see a movie by myself, and I would walk through this cornfield, and I would always look up at the stars at night and just kind of try to comprehend, and and always imagine there was some star out there with a little planet and a little boy looking back at me, kind of thing. So first, I thought it would be great to just understand, when we say the cosmos, what do we mean when we say the cosmos, and how big is it?
Well, when we say cosmos, we mean everything. We are part of the cosmos. Cosmos is also the Earth, the solar system, the galaxy where we live, the groups of galaxies where we live. Everything that we see is the cosmos, and it is really big. It is so big that we actually cannot understand how big it is. We can put a number on it. We can say, oh, it's something like 100 gigalight years. That is just a number, but we actually, our mind cannot understand the size, that size. So we have some tricks to try to understand, and we will be talking about this, I think, a little bit.
Yeah, absolutely. And is there a way to kind of, people say, well, there are, as many, galaxies as there are grains of sand on the earth, or right, there's these ways to kind of try to wrap our heads around it. And it is true, because when I even just, even when I start thinking about the size of our solar system, let alone the size of our galaxy, once we get to just our galaxy, I'm pretty much, I'm having a tough time. And then, of course, beyond that, even trying to comprehend the number of galaxies, how is there ways we can try to understand it, and is it helpful for us to understand such a scope of bigness?
Yeah, these are very, very good points. It is very difficult to understand the actual size of the universe. We can say, okay, there are like 100 billion stars like our sun in the galaxy. There are probably hundreds of billions of galaxies like our galaxy in the universe, but the numbers are so big. It is important to at least have an idea of the size of the universe, because that also helps us put things in perspective. And then, at least to me, it helps me see our problems in the context of the whole universe. For us, are very, very important problems, but also we can see them from a different point of view. Sometimes problems seem very big, but then when we see, okay, this is part of a really, really large universe, they are probably not so big. We can address these problems.
True. And it is amazing, because even the things that we think are global, this past year in the pandemic, in the context of even our solar system, let alone our galaxy, let alone the universe, infinitesimally small. So I guess
they're very small, yet they're also very important for us.
True. So
these are our reality. Even though our reality is just the reality that we perceive is just a very small part of the reality of the cosmos, is very important. This is our reality. This is our responsibility.
Right. Yeah. And in a way, I guess we could understand that the cosmos, the global, the beyond global, the cosmic perspective, but we live locally, and what we experience is local. So it's
Yes,
interesting that these things are so big, it's really almost impossible to try to comprehend this. But you have stated in the past, like thinking about some of these largest things, you've related them to cucumber cells and giraffe spots. So how could you explain that?
yes,
How
and
so?
yeah, there are also the processes. Well, the universe looks very complex to us. When we look at the galaxies, how they are distributed, they don't follow a random pattern. They follow very, very specific patterns. I actually have an example here. So I don't know if you can see it. This is a 3D print of computer simulations of a part of the universe. This box measures 100 million light years from side to side. It's a good part of the universe. And what you see here in plastic are regions that have a high density of matter. So we will expect galaxies to form in these regions, where the plastic is. So you see the universe at very large scales has some structure. It's not just some random stuff. It looks like cheese or like sponge.
Right.
And it has this structure because it follows some very simple rules, very simple processes that we see in nature in all its scales. We see it in the cucumber cells, we see it in the giraffe spots, we see it in the spots in a turtle. Everywhere we see it. In this case, this is a Voronoi process. It's what happens when you have little seeds that grow, and the places where they grow, you have in these intersections, in the case of the universe, matter accumulates. So you have regions that are, the matter is going away from these regions and accumulating at the intersections. So that's what you see here. So the matter grows from these regions and accumulates here. We see this everywhere in nature, and because we have the same process in different scales, we see the same patterns. That's why we see this could be also the picture of a system of cells in 3D. And they look like that because they follow the same processes.
Right. So it's fascinating. And so why is it that something that's on a even, microscopic level is assembling itself in the same way as what's happening at a cosmic level? Well, what is happening in the cosmos that is it just the same underlying principle of attraction of matter? But why is it happening in the same way?
Yeah, that's a very good question. These are different processes. In the case of, let's say, foam, this also happens with foam, is basically pressure. In the case of the universe, is gravity. What happens is that right after the Big Bang, the universe was almost homogeneous, but there were small differences in density. Some places were slightly more dense than others. So regions that were slightly less dense, these regions could start losing mass to the regions that were more dense or denser, like these edges. So the regions that are slightly denser, they could attract more matter. So the matter goes into these regions, and then other regions get empty. So it's just this process that matter going away from underdense regions and accumulating in dense regions.
Gotcha.
When
And
you have that happening in 3 dimensions, you produce these kind of patterns.
right. And is that continuing to grow? So in other words, as the universe, and correct me if I'm wrong, because I'm coming from my arts perspective, as the universe is expanding, do we find that continues to take place where matter continually compresses and gets closer to each other? So the areas of space of no matter or dark matter are growing?
Yeah, that's a very good question. So our current understanding of cosmology is that there is a component that we call dark energy that is dominating the dynamics of the universe. And dark energy is accelerating the expansion of the universe. Because of that, the universe is now in a state of, it's like it's frozen. Actually, since already quite a while, the universe began freezing, and right now the universe at these scales is frozen. At smaller scales, still things happen. We move around the sun, and the sun moves around the galaxy. But when we go to larger scales, at the scales of tens of millions of light years, the universe doesn't change so much, and we think that the universe will not change anymore at these scales. So the universe got at this position, and now it's expanding so fast that things cannot catch up, and then it's frozen.
Wow. Wow. Again, very tough as I try to wrap my head around it. And one of the other things that I know you have referenced is that, you know, we're kind of on the edge of a cosmic cliff. What does that mean?
Yeah, so this is not so well known, but we literally live at the edge of a cosmic cliff. So the Milky Way is located more or less at the center of something that we call a cosmological wall. Let me find one. For instance, here you see there is a little wall here, like a membrane.
Yeah.
That is dividing these two empty regions. So the Milky Way is sitting at the center of this membrane. And if we move through the membrane, we find Andromeda galaxy and we find other galaxies. But if we move perpendicular to this membrane, we actually fall into a void. This is a very large void. This is probably like more than 200 million light years in diameter. So that means that if we were to travel, if we had a spaceship that travels at the speed of light, we will be traveling for 200 million years until we reach the other side of the void. And it's just right there. So we just have to step out of the Milky Way in that direction, and we are already in this area.
Wow. So, and how close are we to that void? How close is the void to us?
As soon as we step out of the Milky Way, we are already inside that void.
Wow.
Yeah, so we are in this membrane.
Wow.
And we can move through the membrane and find other galaxies. But if we move perpendicular to the membrane, we step into the void. And there is nothing there.
And there's just absolutely nothing, literally traveling at the speed of light for 200 million years, nothing. Yes.
We will find some galaxies here and there. There are a few galaxies scattered inside, and they're actually very interesting because they are very rare. We find a few galaxies, but we could find paths within this void that will be just dark, and we will not encounter anything for 200 million years.
Right. Wow. And that's just, it's amazing just trying to understand and wrap our heads around this.
Yes, and so
what's interesting is you often talk about how you're at this intersection with cosmology, using data science to understand these things, but also art. And so I was wondering, how do you feel that cosmology relates to art and artists?
Yeah, so I don't see myself as an artist, but more what I try to do is try to present the beauty of the universe, because the universe is beautiful in itself, just like this that I show you. Let me turn it. We can turn it on here. This is, to me, this is a little piece of art. This is it's a beautiful structure, and I didn't have to do anything to create it. It's just the structure of the universe. So when we look at, for instance, I have another one here. This is a cosmological void. It's one of these empty regions, and this is the network of galaxies around the cosmological void. This is beautiful in itself. The only thing that I have to do is just find a way to present it, find a way to make it real. Now, this is something that is kind of abstract in the universe. I just print it and make it some physical object that I can touch.
Right. Wow.
So the universe is beautiful.
Right. It's literally this extraordinary, uncomprehensible piece of art that just surrounds all of us.
Exactly. Yeah, that's a very good way of seeing it.
And how we look at it. Well, that's amazing. It's truly extraordinary. Unfortunately, we're just about out of time, but just curious, do you have any artistic discipline that you do yourself, or just artistic practices that you love, appreciating or watching or hearing?
Yeah. Well, I like, I think, painting, but I play guitar, and I find that a very important part of my life, being able to express myself in a different way, with music in this case.
That's amazing. Well, Miguel Aragon, thank you for helping us gain knowledge through the lens of creativity here on Artful Science.
Oh, thank you, Aaron. Thank you very much. It was a pleasure being here.